solve the system of linear congruences 4x congruent to 5 mod 9, 2x congruent to 6 mod 20. First take the given data. In previous problems, they have given the linear congruence in the form x is congruent to a1 mod m1, x is congruent to a2 mod m2, etc. up to x is congruent to ar mod mr. But in this problem, they have given the problem is of the form ax congruent to b mod m. So we have to first reduce this linear congruency to a system of linear congruency form. That is, we have to reduce this to an x is congruent to a1 mod m1, x is congruent to a2 mod m2 form. For that, first take the first congruency, that is 4x congruent to 5 mod 9. We have already discussed in the previous videos. We have to find the solution for this linear congruency. Means first you have to apply the congruence method here. Here 4x congruent to 5 mod 9. By the definition, we can write this as 9 divides 4x minus 5, or we can take 4x minus 5, which is equal to 9 into k. This is by the definition of congruency. So take 5 value to the right hand side and this 4 goes to the denominator. We get the x value as 9k plus 5 divided by 4. That's the value of x. Next step, you have to substitute k values 0, 1, 2, 3, etc. up to 1 to obtain the integer value of x. So put k is equal to 0. If you substitute k values 0 means 9 into 0 is 0 plus 5 by 4. Therefore we get x value as 5 by 4. Obviously 5 by 4 does not belongs to an integer. Next we have to take the k value as 1. If you substitute k value as 1 means 9 plus 5 is 14. 14 divided by 4 is a value of x. That's also a not belongs to integer z. Similarly, substitute k value as 2. We substitute k value as 2 means 9 into 2 is equal to 18 plus 5 is 23 divided by 4 does not belongs to an integer z. Similarly, substitute k value as 3. So 9 into 3 is 27 plus 5 is 32. 32 divided by 4. So we get 32 divided by 4. 4 ones are 4 8s are. Therefore x value is 8, which belongs to an integer z. Therefore we can conclude that the solution is given by x is congruent to 8 mod 9. For 4x congruent to 5 mod 9, we can take a solution as x is congruent to 8 mod 9. So this reduced to a system of linear congruence method form, that is x is congruent to a1 mod m1. In the similar way, we have to find for this value, that is 2x congruent to 6 mod 20. We can write by the definition, we can write this as 20 divides 2x minus 6, or we can take this as 2x minus 6 is equal to 20 into some integer k. So take 6 value to the right hand side and 2 goes to the denominator. We get x value as 20k plus 6 divided by 2. Therefore, if you substitute k value as 0 means 20 into 0 is 0 plus 6 by 2. Therefore, 6 by 2 is 3. Hence, x is equal to 3 belongs to integer z. Therefore, we can take a solution as x is congruent to 3 mod 20. So, the congruency 4x congruent to 5 mod 9 reduced to x is congruent to 8 mod 9. Similarly, 2x congruent to 6 mod 20 reduced to x is congruent to 3 mod 20. Therefore, these two are the system of linear congruence. We have to find the solution for these two system of linear congruency. Next, the procedure is same as before problems. Here that is, here we can take a1 as 8 and a2 as 3 and m1 is 9 and m2 is 20. So, procedure is same as before. Next step, we have to verify that the GCD of 9 and 20 is 1. So, here we have only two values, so we have to verify that 9 and 20 is 1 or not. Here we have to verify that the GCD of 9 and 20 is 1 or not. Obviously, the GCD of 9 and 20 is 1 because the divisor of 9 is 1, 3 and 9, but the divisor is 1, 2, 5. Here the divisor is 1, 2, 4, 5 and so on, but the common divisor in these two is 1. Therefore, the GCD of 9 and 20 is 1. After verifying the GCD, next we have to take m is equal to m1 into m2. Here m1 is 9 and m2 is 20. If you multiply 9 and 20, we get small letter m values 180. Next, we have to verify that mk is equal to small m by mk for k is equal to 1, 2 because we have two linear congruency. So, we can take capital M1 as small letter m is 180 divided by small m1 is 9. 180 by 9 is 20. Similarly, m2 is 180 divided by small letter m2 is 20. Therefore, we get 9. m2 is 9. Next, m1 is 20. m2 is 9. Therefore, next step, we have to consider a linear congruency mkx congruent to 1 mod mk for k is equal to 1 and 2. So, we get mk is 20, x congruent to 1 mod m1 is 9. Similarly, m2 is 9, x congruent to 1 mod. Here, this m2 value is 20. Next step, by inspection method, you have substitute x values and check the congruency. So, by inspection method, x1 is 5 and x2 is 9 here. So, we have to substitute x as 1, 2, 3 and check the congruency. Here also if we substitute x value is 1, 2, 3 and check the congruency, we obtain x1 value is 5. For this congruency, the x value is 5. For this congruency, x value is 9. So after obtaining all the values, we have to take the formula, that is unique solution of system of linear congruence is given by the formula x is congruent to a1 m1 x1 plus a2 m2 x2 plus etc. and so on, ar mr xr under mod m. So substituting all the values, we get x is congruent to a1 is 8 into m1 is 20 into x1 is 5 plus a2 is 3 into m2 is 9 into x2 is 9 under mod. Here m is 180. So simplifying the values, we get as x is congruent to this value becomes 800 plus this value is 243 under mod 180. So if you add the values, we get x is congruent to 1043 mod 180. So reduce these values to a lesser value. So we have to divide 1043 by 180. So we get 180 into 5 as 900, which is close to 1043. So subtract these values, we get the remainder as 143. So in the place of 1043, we have to substitute as 143 because 1043 is congruent to 143 mod 180 satisfies. Therefore, x is congruent to 143 under mod 180 is a unique solution for the given system of linear congruency. So this completes the problem. So these are all some of the question paper problems on finding the solution of system of linear congruences. So in this video, we studied about Chinese remainder theorem, and using that Chinese remainder theorem, we solved some of the problems. In next video, we study about Euler's theorems, Wilson theorem and Fermat's Little theorem.